Okay, Lemma1. So Lemma1 says to convert from the representation of the vector v with respect to b to its representation with respect to d, we use the change of basis matrix. Incidentally, a more appropriate term would be change of representation matrix, but again, this is standard, so we're going to stick with it. Anyway, so again, to convert from one representation of vector v with respect to b to its representation with respect to d, we're going to use the change of basis matrix, and we're going to multiply this this representation by the representation of the well, this would be the change of basis matrix, right? And so we're going to multiply that. We're going to multiply the representation with respect to b by that to get the representation of the vector with respect to d. Now, conversely, if left multiplication by a matrix changes bases. In other words, if we have some matrix times this gives us the representation with respect to d of the same vector, then guess what? M is a change of basis matrix. Okay, so we've got one that we got a way we can check as well. Now the proof of this is pretty straightforward. The first sentence holds because matrix vector multiplication represents a map application, and so the representation with respect to b and d of the identity, right? So the identity mapping times the represent of this, right? So this times this gives us well, let's write it down. So if I have easier just to write it down. Okay, and so this is going to equal what? So to get to here, this is going to equal what? The representation with respect to b of the identity of v. And then, of course, that's just going to equal that. And that's going to hold for each vector. Now, for the second sentence, with respect to b and d, the matrix M represents a linear map whose action is to map each vector to itself, and is therefore the identity map. Okay. All right. Let's do some examples.